Isotopes and Ion Charges lab. So in this lab, we're going to look at collections of shapes that represent different atoms. The big squares are protons, the circles are neutrons, and then the little cubes are electrons. And if you're doing this lab at home, you're going to look at pictures of these collections. And you'll need your periodic table handout for this, which is linked here. We're going to use that. So we're going to jump in and we're going to try collection number 7. And let's see, one term we need to know is what an ion is. An ion is an atom with an unequal number of protons and electrons. And because the protons and electrons, those are the charged particles, when they're unequal, that means that atom will have a charge, which means it's an ion. Ions are atoms that have a charge, an electric charge. So let's look at collection number 7. This link here is a folder that has pictures of each collection. So here's the picture of collection 7. And notice that we have 1, 2, 3 protons, represented by the squares, 1, 2, 3, 4 neutrons, represented by circles, and 2 electrons, represented by cubes. So let's go back and record that. So we have 3 protons, 4 neutrons, 2 electrons. Now we have to determine what element it is. So the important number for determining the elements is the number of protons. So let's look at our periodic table. The number at the top of each element is the atomic number. Very important number. And the atomic number is also the number of protons. It's what determines the identity of the element. So if something has 7 protons, it's nitrogen. If we add one more proton, it becomes oxygen. We add one more proton, it's 9, it becomes fluorine. So we just had one where we identified it had 3 protons, so that's going to be a small element. That's going to be lithium. So let's look here. So we're going to, what happened? Sorry. Okay, we're back. So that's going to be lithium, so we're going to put an Li, that's the symbol for lithium on the periodic table. And then we're going to put its mass number next to it on the upper left corner. The mass number, because you might remember from our notes, is the number of protons plus neutrons. So let's write that down here. Protons plus neutrons is the mass number. In this case, we have 3 plus 4 is 7, so it's going to be Li, and then we're going to put the little 7 up here in the upper left corner. And then we have to determine if it's an ion. Does it have a charge? Let's look here. So here's our picture. Oops, that's it. Here's our picture. Each time you have a proton and an electron, so here we have one proton-electron pair, they cancel each other out in charges. A positive charge and a negative charge, they cancel each other out to be neutral. And we have another pair that cancels out. But then we have a proton that is not canceled out. We have one more proton than electron. So that means this atom is going to have a +1 charge. So we're going to write Li plus. Okay, let's do another one together. Let's do one. I guess I'm doing collection 3. Okay. Actually, yeah. Okay, so here's collection 3. Okay, so collection 3 has 1, 2, 3, 4, 5 protons. 1, 2, oops, these are neutrons. 1, 2, 3, 4, 5 neutrons, 2 electrons. Five, 3. If we look on our periodic table, the element that has 5 protons from its atomic number is B, boron. And then its mass number is protons plus neutrons. So 5 plus 5 is 10. And then this is also, looks like, going to be a positive ion because it has 3 extra charges, 3 extra positive charges. These cancel each other out. And then we have 3 extra positive charges. So this is going to be B, and then we're going to write a 3 plus. Some of these will be negative charges. Those will be ones where there's extra electrons. So if I have 2 extra electrons, like let's say, what's an example? Common example. Sulfur often has 2 extra electrons, so its charge would be S2 minus because it has 2 more electrons than protons. Some of these will have no charge, so you can just write no charge in this little column here. So some will have no charge. And then you'll answer a question, which of the above atoms are isotopes of the same element? And remember that isotopes have same number of protons as each other, but different numbers of neutrons. That's what makes 2 atoms isotopes of the same element. And that is in your notes too, you could look that up. When you're done with that, then you're going to fill out this practice table. So let's do one of these together. So here we have each column is a separate atom, like above. Let's try this first one. So we know in this one we're given the name of the element, neon. And we're given the mass number and the number of electrons, but we don't know what goes in these other boxes yet, so we have to figure that out. So let's first see if we can figure out the atomic number, which we know from above is the number of protons. And the mass number is the number of protons plus neutrons. Right? So let's look for neon on our periodic table. Here's our friend neon right there, 10, atomic number 10. So, 10. And then we know that the protons plus the neutrons is 22. So we have 10 protons. We don't know how many neutrons, but we know altogether it equals 22. The reason it's called the mass number is because the protons and the neutrons are the heavier particles inside of an atom. The electrons weigh almost nothing compared to the protons and the neutrons, so they don't contribute to the mass. It's just protons and neutrons. So the number of neutrons here must be 12, right? Because 10 plus 12 is 22. So then the isotope notation, we're going to take the symbol Ne. We're going to write it in 2 different ways. We're going to write it like we wrote it above, where we write the mass number in the upper left corner, and then the other way to write it is to put a dash and then the mass number right here. And now we're going to figure out if this has a charge. So here we have 10 protons, so 10 positive charges, and 10 negative charges. Aha, that's equal. Those are equal positive and negative charges, so this is going to be no charge. Let's maybe try one more here. Here we have a -1 charge, and we have the symbol I-127. So what does that I stand for? We're going to need to use our periodic table. Here is I right here, that is iodine. And iodine's atomic number is 53. Let's write that in. So we know it's iodine. And we know the atomic number is 53. And the mass number is 127 from here. So we can say I-127. We can also write it like that. And then I'm going to let you guys figure out how many neutrons must it have. And then how many electrons must it have if it has a -1 charge? There's 53 positive charges. How many negative charges would there need to be so there's an excess of 1 negative charge? There would need to be 54. Okay, so I'll let you do the rest of that yourself.